Now that we've taken a look at simplifying radicals, let's go back and take a look at multiplying. And this time we're going to have to simplify after we multiply. So just going back here for a minute, when we started out, when we did this multiplication here, there was no simplifying involved because as it happened, none of these answers were able to be simplified. These were specifically chosen to show you how to do the multiplication, and you didn't have to worry about the simplifying because it couldn't happen. But now that we do know how to simplify, we're going to look at examples where we're going to multiply, and then there's some simplification that will need to occur. So there's going to be two approaches. I'll show you both, and then you can decide which works better for you. The first approach is just to do the multiplication that you see. So here, square root 6 times square root 2 is equal to the square root 12. Now we have to think about simplifying 12. So factors of 12 would be 4 and 3, 4 being a perfect square. Square root of 4 is 2, so 2 square root 3. And that would be our answer. When we multiply, by the very nature of multiplication, we're making numbers bigger. And the bigger the numbers, sometimes the more difficult it can be to simplify because it might be more challenging to see the factors and which of those factors are perfect squares or whatever the root is we're looking at. So another approach that you could use would be to factor before you do the multiplication. So here, 6 is 3 times 2, and then we have the square root 2. Now, let's do our multiplication, which means we just put all the factors under the same radical. So we have 3 times 2 times 2. So we have our answer, the same 12 we had up here, but now it's in factored form. So the rule is for square roots, we need 2 the same to pull one out. So I got 2 2's, and now I pull one on the outside. So our answer would be 2 square root 3. Same answer, just different approaches. Next example, we're looking at cube roots. So first approach is just do the multiplication as you see it. So remember, you can only multiply when you're looking at radicals, what's under the radical with whatever is under a radical. So 16 and 2 can be multiplied. This 10 and 5 are the outside. So they get multiplied. This radical 2, this 2 under here, does not get multiplied by the 10 because that 10 is not underneath the radical sign. So 10 times 5 is 50. We multiply the numbers outside the radical. And now inside the radical, 16 times 2 is 32. So we've done the multiplication, and now we work on simplifying. So here, cube roots, 32, 8, and then times cube root of 8 times cube root of 4. 8 times 4 is 32. And then finally, well, not finally because we have another step, cube root of 8 is 2. So we have this 50. Now we have the 2, the whole number 2, from the cube root of 8. And then we have this cube root of 4. So finishing this multiplication, 50 times 2 is 100 cube root 4. This 4 under the radical is not multiplied by the 50, the 2, or the 100 because these are not in radicals. So that would be our answer, 100 times the cube root of 4. Or we could do our factoring before we do our multiplication. So we have 10, and then cube root 16 is 2 times 2 times 2 times 2 times 5, and there's no factoring to do for this 2. It's just the square root of 2. So now we can do our multiplication. Again, the 10 and the 5 are outside the radical, so they get multiplied together. 10 times 5 is 50. And now we're going to collect all our factors under the same radical. So we have 1, 2, 3, 4 2's there. And then we have the factor of 2 from here. So we're just gathering all these factors under one radical sign. For cube root, we need 3 in order to pull one out. So I have 3 2's there. And so 50, when I take the cube root of these 3 2's, I get 1 2 on the outside. And now what's left under the radical, 2 times 2 is 4. And finally, 50 times 2, 100 times the cube root, of 4. Same answers. This, you do the multiplication first, then simplify. This, you factor each of your radicals. Then your multiplication is just listing all the factors under the radical and simplifying from there. Last example, we are looking at fourth roots. So here, what I'm going to do is I'm going to do the multiplication first. I should point out, in the first 2 examples, there were no variables involved. So either method is absolutely, they're both correct, but whatever you choose. When we have variables, I do suggest that you do the multiplication first and before, don't bother to factor. This will get a little bit cumbersome. So do the multiplication with the variables, and so you'll be adding your exponents and then simplify from there. So what am I talking about here? 4 times 8 is 32. Now, x squared times x6, we're multiplying, so we add the exponents, and that is going to be x to the 8. And now y times y3 is y to the 4. 1 and 3 is 4. Now we're going to simplify. 32. 32 factors, 16 times 2. And again, you can always do your prime factors here to figure out how you could simplify this. But these are ones hopefully you're starting to recognize. So 16, and then over here we have our 2. 16 times 2 is our 32. Now x to the 8, we're going to divide by 4. 8 divide by 4. Yep, we can do that. So that goes here, and then y to the 4. 4 divided by 4, we can do that. Just a heads up, in this particular case, it worked out that after we did the multiplication, the exponents were nicely divisible by our root. It doesn't always work like that. It just happens to be in this example. You might have to do some more work here like we did in previous examples. So fourth root of 16 is going to be 2. Fourth root of 8, 8 divided by 4 is 2, so we have 2x squared. Y to the 4. 4 divided by 4 is 1 for y. And then that, fourth root of 2 just sits. We can't simplify that anymore.